So good afternoon, everybody, and as Juliet's just highlighted, I actually do own more than one tie. It's just unfortunate. I used to work for RMC, group of companies that was bought by Cemex in 2005, and we had a company tie, and it was so much easier in those days. Just open the wardrobe, pull out the same RMC tie, and off you went. Now, Cemex is a little bit more relaxed, so we very often wear a tie, so obviously this one's top of the pile. So good afternoon, everybody. So I'm Richard Kershaw, I'm Technical Manager for Cemex UK. So I'm responsible for a team of specialist technical managers who focus primarily on product conformance. So we touched on standards earlier. I've got to make sure my product conforms to the customer's specification and to British and European standards. We give technical guidance on products and applications, product innovation, using existing raw materials as well as niche and novel. And primarily we're around, myself and my department is concrete, mortar, screed, aggregates and dry silo products. And in more recent times, our focus has been on design optimization and mix optimization to produce lower carbon concretes. So a little bit about our sponsor. Yes. So as I say, I work for Cemex. Cemex was founded in Monterrey in Mexico in 1906, and we're one of the world's largest global companies. We've got 40,000 employees worldwide. We're in 50 countries, and we've got a turnover around 15 billion US dollars. Everything that we do is measured in US dollars. And as I touched on earlier, we've got 1,400 concrete plants worldwide. So we are the world's largest producer of ready-mix concrete. We're not the world's largest producer of cement. They sit in China. We're probably about the fifth, but certainly the world's largest producer of ready-mix concrete with circa 50 million cubic meters of concrete per annum. So in the UK, we make 1.8. Worldwide, we make 50 million. Here in the UK, we have aggregates, including a marine operation and more, and we'll touch on biodiversity, but we're really struggling to find opportunities for new or extending our quarries. So we're focusing on dredging in the English Channel and the North Sea. We've got asphalt, so the material that goes on the road is asphalt, not tarmac. That's a competitor. So it's asphalt, concrete, mortar and screed, as I've already said. Building products, including a precast rail solution, and we have cement. So we have a cement works in the centre of the country in Rugby, and we have a grinding mill and a blending mill in Tilbury on the East Coast. We also have admixtures, and I think Natalie, she touched on earlier in terms of the benefits you get from chemical admixtures. And we also have a business silo solutions where we dry materials and we put it into a silo where you just add water and you've got a ready-to-use material. So I've been doing concrete for an awful long time. I'm probably now in my 39th year of working in concrete. Before that, I worked in a test laboratory, and now I'm 36 years as a concrete technologist working for Cemex. So concrete is the most important material. I think Stafford touched on that earlier in terms of the amount that is produced each year. So it has a positive impact both in terms of regional and economic development. Okay, so it's vitally important. It's important for infrastructure, as we see here. So clean water, if we think about Thames Tideway, if we think about low carbon energy, Hinkley Point. So Hinkley Point takes masses and masses of concrete, durable homes, schools, roads, and of course HS2 in the terms of railways. We use responsibly sourced materials, so BES 6001. So we are judged on the raw materials that we use as we make concrete. It can be bespoke design, so a plastic concrete can be moulded into any shape. Okay, so if you think about some of the buildings as we walk around London, looking out the window, that's not the most dramatic of shapes, but it could be a bit more curved if it chose to do so using plastic concrete. We can design it for early age compressive strength, so particularly if we think about repairs, you can design a concrete which goes off very quickly and gives you high strength in 4 hours. So a lot of airport runways are repaired with concrete that will give you 40 Newton, which is a very strong concrete, in 4 hours. We can go the reverse and we can give you set retardation, so we can keep that concrete plastic for a lot longer. One of the conversations we had during the sort of mini breakouts was the limitations as we've got in concrete plants. And the major limitation is it's time limited. You've really only got about 2 hours from water hitting cement to place, compact and finish that material. So you can't traffic it long distances, which is again one of the benefits when it comes to lower carbon because of the low transport elements. It has loads and loads of performance benefits. Okay, it's got thermal mass benefits, potentially omitting the need for heating and cooling of a building. Okay, it's got flood resistance, it keeps water in and it keeps water out. Okay, so you can do all those things with concrete. As Philippa touched on, it's 100% recyclable. So you can take that building over there if you so wish, and you can demolish it, and you can actually reuse all of that demolition waste back in your concrete. And there's an interesting challenge going on already there, where do we use that demolition waste for a crushed concrete aggregate, or do we use it to make cement? Which is better for the environment, which is better in CO2, which is more cost effective. So Philippa and I have got a challenge here. I want to use it as a recycled aggregate, a crushed concrete aggregate. Cambridge Electric Cement want to use it in electric arc furnaces. And I'll touch on electric arc furnaces and the negativity around electric arc furnaces from my point of view later. It's an effective soundproofing material, okay? It doesn't rust, it doesn't rot, it doesn't emit smoke, it doesn't fuel a fire, okay? So, you know, if we think about timber, my arch enemy, and steel, my arch enemy, you know, they potentially emit smoke and they potentially fuel a fire. Concrete does not do that. We're a consumer of waste, whether that's recycled aggregates from demolition waste, crushed concrete aggregates from returned material, fly ash from coal-fired power stations, or GGBS from blast furnace metal manufacture. And of course, if we use these recycled materials, we keep them out of landfill. So we have future in action, okay? That's the big headline when it comes to Cemex Global. And what driving that is because we're fully aware that our production processes have a carbon footprint. I think as Stafford touched on earlier, you know, circa 5 to 8% of the CO2 emissions for the world come out of cement manufacture, okay? Cement manufacture, not concrete manufacture. In the UK, it's about 2%, okay? It's 2% because there's not as much production as there is in other parts of the world, but it's also a very defined and controlled process, okay? So our future in action is all about sustainable excellence, it's all about increased circularity, it's all about better natural resource management. You know, as I touched on earlier, 1.8 million cubic meters of concrete. My largest quarry, which sits just outside the Peak District in Derbyshire, produces 5 million tonnes of aggregate per annum, digging and blasting very big holes in the countryside. That brings its own challenges when it comes to wanting to extend that quarry, because who wants a big hole blasted in the hillside just outside Buxton? Hence recycled aggregates, hence marine aggregates. So we've got 6 pillars which help our Future in Action programme, okay? So what we're focused on, and I always remember to press the button. So we're looking at sustainable products and solutions, okay? So not just lower carbon materials, what products can we actually manufacture which aid a more sustainable construction? Decarbonising our operations, that's key. As I say, we recognise that making cement results in large emissions. Somebody touched on earlier about actual numbers for cement manufacture. There are generic numbers used. The Mineral Products Association has fact sheet 18, which gives a generic number around about 840 kgs of CO2 per tonne of CEM1. CEM1 is Portland cement, OPC, so 840 kgs of cement produced. If you come to Rugby, it's 734 for CEM1. My CEM2AL, which is a blend of clinker and limestone fines, is at 709. So it's really important to engage with your actual concrete and cement supplier to get the actual numbers, because there is that flexibility. So if everybody uses 840, then you know that's a much higher number than mine is using. And circular economy, the challenge around the use of recycled materials, crushed concrete aggregates, the use of the rain that falls from the sky. We want to be incorporating all of that back into our concrete. So if we focus on decarbonisation or operations, there's 2 main levers in the UK that we're looking at. So one is all about reducing clinker factor. So clinker is the pure cement, as Philippa touched on, and we're looking to effectively dilute that with fly ash from coal burning power stations and limestone fines, which Natalie has already mentioned is abundant in the UK. And also alternative fuels. So we burn pretty much anything with a calorific value, but at the moment we're focusing on biomass, which really is the household waste, and stopping it going to landfill. So we burn that to fuel our kilns rather than fossil fuels, and that all helps in the reduction of CO2 per tonne. The other three we're focusing on is around water, biodiversity and air quality. We think it rains a lot in the UK. There is actually water scarcity in certain parts of the UK. The southeast, Devon and Cornwall actually don't get an awful lot of rain. And if you think we use, including cleaning the truck mixer, cleaning the plant mixer and the concrete that the water that goes into the concrete, we use about 203 litres of water per cubic metre produced. 1.8 million times 203. Somebody better than me can work that maths out, but it's an awful lot of water. So there's a huge focus on using reclaimed, recycled or borehole water. Innovations and partnerships, that's why we're here today, and also promoting a green economy. You know, that's why we're here today. So lots of what you'll see, not only from Cemex, but from my colleagues in other supply industries, so Tarmac, Heidelberg, Breeden, et al. Will be all about innovations and partnerships and promoting a green economy and talking about lower carbon concretes. So I think as Natalie touched on, there are lots of raw materials that go into concrete. So we have cement, and we have additions, particularly fly ash and GGBS, coarse and fine aggregate, which is stone and sand, okay, but they're all aggregates, admixtures, additives, and water, and each one of those comes with its own European standard. So everything we do is driven by standards, whether that's raw materials, whether that's testing of the raw materials, whether that's testing of the concrete in its plastic and hardened state, designing of the concrete, and of course going back up to the asset owner whose engineer is designing the structure. It is all driven by standards. So those standards bring their own challenges when we're looking at niche, novel, new cements. How does that niche, novel, new cement sit with EN 197 Part 1, EN 197 Part 5, or EN 197 Part 6, which are all rather sexily the British and European standards associated with the manufacture and testing of cement. So aggregates, main component of concrete, take up the bulk of the volume and are very low in carbon. Okay, very little processing, maybe a bit of washing, maybe a bit of crushing, but typically an aggregate will have somewhere between 3 and 5 kgs of CO2 per tonne produced. Okay, whereas cement will be up around 734. I think we do recognise that, you know, from quarrying of the raw materials to heating it to processing it, cement takes up the bulk of the CO2 in concrete, typically around 80%. So if you see a number of 173 kgs of CO2 per cubic metre, around 80% of that will be the cement. It won't be the aggregates, it won't be the water, it won't be the admixtures, and it won't be the additions. So I keep mentioning additions, and there's a long track record of using byproducts from other industries. Okay, primarily fly ash coming from coal-fired power stations, and GGBS coming from blast furnaces. And as Philip has already touched on, you know, steel manufacture is reducing in the UK, so that's accepted. And most steel manufacturers are now moving away from blast furnaces to electric arc furnaces, so GGBS is a constrained source. I read somewhere, I live in Nottinghamshire, so I read somewhere that the last coal train came into Radcliffe-on-Trent power station 2 weeks ago. So once that's used up, that power station will close off, so we'll no longer have fly ash available from that power station. So again, using that addition, using that fly ash becomes a more constrained source. So the real opportunity is what's the next addition for durability reasons and lower carbon reasons for use in concrete. Silica fumes, calcined minerals, natural pozzolans. Somebody mentioned the Romans. Natural pozzolans were used by the Romans, and limestone fines. They're all around the periphery at the moment of being used in concrete production. They currently sit in standards. We don't make them. Our competitors don't make cement with those additions. So I think the space that we're all fighting in is that next addition to replace GGBS from a durability point of view and from a CO2 point of view. We as Cemex are looking at landfilled ashes. There's an awful lot of ash that sits in the ground. I think Hive are suggesting there's around 70 million tonnes of landfill lagoon ashes which have been placed in the ground over the years. The challenge we've got there is recovery rates. So how much per tonne can I recover from per tonne dug out the ground, and what's the reactivity? Will it work in concrete? Okay, at an industrial scale. We've mentioned standards a couple of times. We've seen changes to product standards in BS 8500. So prior to November 2023, we typically made a binary cement, clinker plus an addition. Okay, CEM 1 plus slag, CEM 1 plus fly ash, or CEM 1 plus limestone fines. November 2023, new standard was amended, which allowed us to use ternary blends. So we can now use CEM 2 AL, Portland limestone cement, clinker with limestone, plus GGBS. So I've got 3 components now rather than 2. And that leads again to lower carbon. I am reducing the clinker factor per tonne of cement produced. So raw materials, huge focus, particularly around recycled materials. The prime one really is about, I think if that works, no it doesn't, so I'll have to point. The prime one is around cement. How do we decarbonise that? And how do we find the next addition? So what we've done over the years is develop a range of lower carbon concretes that lead into more sustainable construction. So back in March 2020, probably the best and worst time to launch a product, 3 days before the country went into lockdown, we actually launched Virtua, lower carbon by design, which was all about the use of additions all around mix optimization to result in lower carbon concrete. But I think it's been recognised since then that we can add more to construction. It's not just about lower carbon concrete. Yes, it plays an awful important part of it, but what about design optimization? How do I make that building over there that's being constructed lower in carbon? Okay, can I use high performance materials, which we'll touch on later? Do you actually need 80 Newton concrete in the columns? Can you make that with 40 Newton concrete? You know, when I first started in 1988, looking around the room, there's not that many people that will probably remember that. But when I first started in 1988, 40 Newton concrete was a high strength concrete. Everyone got excited about it. The whole office came out to have a look at us making 40 Newton concrete. My average strength in London now is above 40 Newton. That's an average strength. So you imagine I'm making 70, 80, 100, 110 Newton concrete because we're all striving for thinner structures to create more footprint. So my space to rent is greater. And to do that, to build higher, you need thinner sections, so you need stronger concrete. Stronger concrete needs more cement needs more CO2. It's as simple as that. But if I can actually use less concrete in my structure, perversely by making it thinner, by using high performance concrete, is my overall build lower in CO2? And that's a whole area which isn't currently really being looked at by the industry, by the construction industry. We focus massively on CO2 per cubic metre. What can we do to reduce that? Rather than if we built it quicker, because we were using high performance concrete, which gave you 40 newtons in 2 days rather than 40 newtons in 28, and I built it quicker, I've got less resource on site, I switched the kettle on less, I've got less people travelling to the site, so my overall build has a lower CO2, and I think that's quite an exciting area around design optimization.
Richard, sorry to jump in. We're going to need to wrap up.
Okay, right. Okay, I get very excited about this. So, energy efficiency. Okay, so we want to use more concrete to add thermal benefit. We want to conserve water. Okay, so we can make concrete that keeps water in, keeps water out, or actually allows the water to flow straight through. Lower carbon, as I've already touched on, and recycled materials, and I will continue the battle with Cambridge over the best use of construction waste. So, hopefully this will work. So we've got high performance concrete, 100 megapascal concrete with 30 Newton flexural strengths. Okay, for those that keep a close eye on Grand Designs, that was the Grand Designs concrete house. Have a look at it. I accept it's not the prettiest of house. I spent 2 years designing the concrete for that, so please be kind. We've got self-compacting concretes, and you think, well, that's a fairly simple technology. That came out of Japan in the early 90s, so it's not new technology. But if you think about the noise associated with concrete, you can hear demolition going on. But if you heard a poker vibrator going and a pump going, it's very noisy. So you need less resource, and less noise associated with self-compacting concrete. Every single concrete producer does this. They fill a concrete truck with water and then they spill it onto the floor. Okay? And it drains away. So you've got two options. You can either keep that water and you can use it in bathrooms or watering plants, okay? Or you can just let it soak away back into the ground. So it's not going into the sewage system, it's going back into that natural water cycle. So those just three elements, they're not necessarily lower carbon, but they potentially add to a more sustainable construction. Cemex Ventures, they're our venture capital and open innovation unit of Cemex, okay? So they're looking for startups, not necessarily to invest in, but to support. And what we're looking at, we've got 25 startups, carbon upcycling being one of them, the use of recycled glass in cement production being another, but this is the area we're really focusing on. Management and construction of industrial waste. So can we capture it, process it, and use it rather than primary materials? How do we improve our water efficiency so we're not using mains water? We want to be using recycled and reclaimed water. Decarbonised materials, great article I read earlier today. My colleagues in aggregate industries, so Holcim outside of the UK, aggregate industries in the UK, are using waste pottery in cement production. Okay, so that's a decarbonised material because somebody else has taken the carbon and they're using that to reduce the CO2 per tonne. We're also looking at the future of construction. So what does 3D printing really look like? Is that an opportunity? What does digitalisation look like? Okay, so you'll see lots of Maturix and geotech looking at how we measure concrete behaviour in the structure to make the construction go quicker. And then, as I've already touched on, alternative additions. Somebody arrives tomorrow with 1.8 million cubic metres equivalent of GGBS. Yeah, there's a real opportunity there. So, very quickly in summary, apologies, Juliet. So, concrete, very essential, okay? All the things we've touched on, whether that's Thames Tideway, starting with Lee Tunnel in 2010, whether that's HS2, concrete is hugely important. We do recognise that lower carbon materials and more sustainable construction materials are just an interim solution while we work on technologies to reduce the carbon emissions in cement and concrete. And that's very much our focus as Cemex. We're not necessarily focusing on carbon capture, storage and reuse. We want to reduce the carbon in the first instance rather than make the waste to throw away. Cemex Ventures do offer that ideal opportunity. They're a separate business to the business I work for, but they do offer that opportunity. And we are committed to being a net zero company by 2050. Almost on time.